Welcome to this recording of iOS 211 background modes and file transfers. My name is Rene and I will guide you through this video here today. This class is going to pick up where iOS 210 left. In iOS 210 we introduced backgrounding into different states and then focused on the most common requirements that applications have these days when they want to execute code in the background. In iOS 210 we talked about everything that is related to arbitrary code that is specific to our application. Here today we're going to pick the other two techniques. That's the long-running tasks to perform specific operations without any time limits, and we also want to see how we can transfer files while our app is in the background and even continue these file transfers in case iOS decides to terminate our app, maybe due to memory pressure. We're going to start by recapping the iOS backgrounding techniques that we introduced in the previous class. From a high-level perspective, there are three ways of executing code in an application that is currently not the one the user is interacting with. We have to understand the different concepts to be able to pick the correct backgrounding technique. The very moment when we leave the current application, that means when we press the home button or we follow an interruption, maybe like a calendar pop-up or something, the current app will move into a background state. If an app is in that background state and it does not execute any code, it will be suspended shortly afterwards. A suspended app can be collected or closed and removed from memory by iOS, and the memory that it used can be reclaimed. However, an application can also keep on executing code while it is backgrounded, then it will remain in that background state. A good example would maybe be a music player. In iOS 210, we discussed the first technique to execute arbitrary code. That was finite length tasks. They allow us to execute some code for a limited amount of time. We have seen that in iOS 7 and iOS 8, this typically means 3 minutes. One of the new APIs that we're going to introduce here today, that's the long-running tasks. Long-running tasks allow us to execute specific operations like playing back music or getting location information. But the good thing about long-running tasks is they do not have the time limit that we have seen with the finite length tasks. And finally, we have background transfers that supports uploads and downloads. These have to go through the file system, and you can continue these uploads and downloads. You can hand them off to the operating system and they will keep on running even if our application gets terminated by iOS. So we covered the first part. Now let's focus on the last two options, long-running tasks and background transfers. Long-running tasks can be used for different operations. We're going to talk about audio today, but you can also realize location updates or create a voice over IP application. Maybe you want to download data for your newsstand content or communicate with some external accessories, and they can be connected either via Bluetooth or to the Lightning connector. Both is possible. We also have APIs which allow us to fetch small amounts of data on a regularly scheduled interval from the server. That would be background fetch, and we have support for remote notifications where our iOS devices can receive notifications. These are pushed to the devices and they will allow us to restart our app to, well, really wake it up remotely. The second part that we're going to talk about, that's the background transfer. We're going to use the file transfer to download a file, and we're going to simulate that our app gets killed and we see that the file will nevertheless be transferred. So as in iOS 210, it's important that you understand when to pick what technique. Finite length tasks for arbitrary operations for a limited amount of time. Long running tasks for everything that is covered by these APIs. And file transfer, well, obviously if you want to download a file from somewhere or upload it to the server. Now let's start with long running tasks. We have already seen that long-running tasks offer various functionalities, and I picked one of them, and we're going to work with this here, and that's playing back an audio file. And we want to keep that playback running even if our app gets backgrounded. So obviously, finite length tasks are not suitable to playback music. That would be pretty annoying if we had to restart the app every 3 minutes to listen to a complete song. Or imagine you have an application that's meant to, well, give you navigation instructions, and after 3 minutes it would simply stop giving you any instructions. Here we have again an overview of all the possibilities that are available with long-running tasks. We are going to cover audio and video in detail later, so I'm going to skip that. But we have, for instance, user location here. User location has even different operation modes. There's a foreground only mode, there's a background mode, there's a mode for significant location changes. That means you get updates less often, but you save the battery life, and this even allows you, just like the background file transfer, to have your app restarted in case iOS had to terminate it. So really, really useful mode. Then we have voice over IP. That's normally used in combination with audio playback. That allows you to configure your application for voice over IP sockets. And again, iOS is going to relaunch the application if there's new data available. So basically, if you say my app supports voice over IP, you prevent iOS from really terminating your app. Then newsstand. If your app is marked as a newsstand application, that means your app integrates into Apple's newsstand program. Then you can keep on downloading magazine content even if the app is not running. Then the background fetch, I also talked about that briefly already. If you regularly download small amounts of data and need to process it, then that's what you're going to use. However, there's no guarantee that the app will be given time to perform anything. The only thing that is guaranteed is that from time to time iOS will launch your app and it will give you a chance to process, but it doesn't make any promises when this happens. What's really nice about this mode is that it learns from the user's behavior. So not only does it restart the app on a regular basis, it also recognizes patterns in the usage of the app. So say you have maybe some social media application, then the operating system will learn that every day before you go to lunch, so let's say around noon, you start that application. So after 2 or 3 days, it will launch the application just before you go out for lunch, and it will fetch all the data. So the moment you run the app, everything will already be there. So really powerful feature. And we have notification support. We can use local notifications to make the user go back to our app. We can have remote notifications. They allow us to wake up the application by sending a message from a remote server. And of course, we have support for Bluetooth and accessories. And this works both directions. So the iPhone can communicate with a Bluetooth device, and the iPhone can also be used as the device that is connected to some Bluetooth module or whatever. And this also allows communicating if the app is currently not in the foreground. So there's a lot of features, and like I said, we picked one of those, and that's audio that we're going to work with today. However, the functionality always is similar. So what we will see is that there are always callbacks that will be triggered, the app is restarted, and then we are allowed to do certain things, and the things we do, they differ depending on what long-running task we use. If we want to use long-running tasks, we first have to declare what exactly our app is supposed to do. And that declaration is called a background mode declaration. If you open the info plist file of your iOS application, then you will find a key that is called UI background modes. The value of this key is an array of string entries, and those entries specify what services, what long-running tasks we want to use in our app. So for us, this will mean we're gonna have audio in there. If we wanted to receive location updates, we had to add the location entry there. We don't have to configure this manually. We can use Xamarin Studio to do that conveniently via the UI. Now the question is, why do we have to set these modes at all? Why does Apple want us to do that? Well, it has two reasons really. The first one is, if we, for instance, pick audio and video background mode, it means that our application will not be suspended as long as it plays some media, some movie or some music. It also means that the application will be restarted on location changes if we specify the location updates value. And for the other modes, we get something similar. Now, the problem with this is, if I'm going to pick the audio and video now, if we play back music, we effectively keep our iPhones busy or our iPads. So we use up CPU cycles, and this is a mobile device, so this is gonna cost us battery life. And Apple wants us to explicitly declare the modes that we use, because they check that we really use them correctly. So the moment we say our application uses audio playback, our app won't be put to sleep. So if there's no need to keep our application awake, then we should not set this flag in the info plist. That will allow iOS to suspend it. But if we set it, then Apple, during the review process, will check, are we really using this? Are we really playing back audio? If not, they are going to reject the app. Likewise, if we say our application uses location updates, but say we wanted to abuse that setting and we only specified it in order to keep our application alive and do something else, Apple will reject the app. And this can go as far as being banned from the developer program if you really try to cheat them and really try to abuse those modes. So only declare them, and if you really need them, and if you do so, use them correctly. We can edit the info plist manually, like I said before, or we select the appropriate modes in Xamarin Studio. Currently, this is not available in Visual Studio, so either open the solution quickly in Xamarin Studio and place the checkboxes there, or edit the file manually. So audio and video is what we are going to focus on here today, because we want to write or code a little MP3 player. Let's have a quick look at how iOS handles audio. I guess that audio and video processing is probably the most used background feature on iOS. It's used for music playback, like the iTunes app, for podcasts. The Maps application uses it because it can give you navigation information via speech synthesis. And So this is really widely used. It supports playback and recording. It can also stream audio and video to an AirPlay receiver like the Apple TV. And before we start with the details of audio playback, we have a little overview here. We do not really have to worry about the specific output or input devices. Nice thing about iOS is it abstracts all of that away from us. So it manages the audio of us. We just let the operating system know what our intention is and how we want to react to specific events that are related to audio. For instance, the user unplugs the headphone. Do we want to continue to play via the speaker, or do we mute the audio? And to configure our audio behavior, we're going to set properties on an audio session object that is available through a single. That session object is of type AV audio session, and this allows us to define the global behavior of our application as far as audio and video is concerned. On a high level, the audio session uses categories and they specify certain behaviors. For instance, if we take the playback category, that ignores the silent switch and it enables background playback. Then we have, for instance, ambient category here. If you select that instead and set that as a category on the audio session, it will mean that it will go silent if the screen is locked on your iPhone, and it'll also go silent if the silent switch is flipped. So this is the first thing we have to do. We configure our session. We define the global behavior. Today we are going to use playback because we want our music to continue playing if the device is locked, if it's turned off, and also if the user has flipped the silent switch, so he doesn't want to receive phone calls, but still wants to listen to music. Activating the session is then the last step here, and be aware that this can fail. The reason is maybe another application already uses the audio session at the moment. Maybe there is already an application that plays back audio exclusively, and so we must be prepared to handle this situation. We gotta inform the user or retry later. However we do it, we should handle it gracefully. If we only set the audio category and configure our session, we're not done. Our app would not continue playing in the background. So we're also going to set that audio and AirPlay background mode. That will then lead to the corresponding entry into the info plist file. With this configuration in place, we can start playing back audio. There is no specific API that we use for background audio output. Instead, all of the media APIs that iOS has can be used. For instance, there's the AV speech synthesizer that you can use to turn text into speech. There's the MP movie player controller. That's the one that shows a preview of the video that is going to be rendered. It has the buttons that allow you to transfer the stream maybe to an Apple TV device. And there's the AV audio player. AV audio player is what we are going to use today. With that, it's very easy to load MP3 files and play them. We start by creating an instance of AV audio player, and we can give a hint about the content that we're going to play. So we're going to deal with MP3 today. So we pass MP3. And if we have configured our session correctly and use the audio player.play method, it will start playing our song, and more importantly, it will continue to play even if we background the app, if we lock our screen, if we turn the device off. To prevent collection of the AV audio player object or the instance that you are using, you should check that you make it class scope. So don't use that locally inside a method, put it into your view controller and use it from there. Otherwise, you might run into problems with the garbage collector. So we have set up everything. We start playing back audio in the foreground. The user leaves the application, presses the home button. Our audio will keep on playing. And iOS will keep our application active until the audio stops. If that happens, iOS will be able to suspend our app. And we have already learned that a suspended app can be terminated. If memory pressure increases, all suspended apps will be removed from memory, one after the other, until enough memory is available. So the question is now, if our app has been terminated, is there a way for us to restart the playback via some external event? And the answer is, yes, there is. We can use what's called remote control events. And these events, they can come from different sources. That can either be the control center, as here on the left screenshot, or it can be the headphones. Headphones often have these remote controls. If you press once the center button, it will start playback. If you click twice, it's going to stop. If you press 3 times, it's going to rewind. So this will trigger an event, and we can react to these events even if our application has been terminated. To register for remote control events is a two-step process. To make iOS call the method above, the app must also ask to receive events by calling the begin receiving remote control events method on the UI application singleton. If the app has multiple screens or view controllers, it can also be necessary to call end receiving remote control events to stop delivery of the events. Because maybe you don't want to receive these events everywhere in your app, but maybe only in one particular view controller. So a good place to put these methods is the view did appear and the view did disappear methods of the view controller that you want to use to react to them. So that's step number 1. The second step, that is, the controller that is supposed to play back the audio, it must override the remote control received method. The event that is passed to the method contains a type and a subtype. And the subtype defines the action that the user triggered. That can be either stop the playback, restart it, fast forward, and so on. And then the application can react to these. So we're going to come back to the diagram that we have already seen before. We know now how we can restart an app. And again, what is really fascinating here, even if our app has been terminated, these remote control events will restart our app. So the app is gone from memory. User presses the play button on the remote control on the headphone. The app is restarted, but it doesn't jump into the foreground. No, it will be started into the background. It will be launched by iOS without the user really noticing. And the music playback hopefully continues if we implement everything correctly. And if we use other background modes, then they use similar approaches. For various reasons, the app is going to be restarted. Some callback will be triggered on the application delegate, and some events or parameters will tell us what the expected behavior is. So we're going to see that pattern again later when talking about the file transfers. But now it's time to work on a bit of code. So we're going to look at the first individual exercise where you'll be coding an MP3 music player and keep the music playing back even if the application has been terminated. Here we are in the class materials file for this lab, and Please move down to the exercises and open up exercise 1, which is about playing music in the background. If you look at the lab resources, you're going to find a starter application that supports playing back music. This is what it looks like, and if you run it as it is, it will stop playing as soon as you push the application into the background. And during this individual exercise, your goal is to fix it so that it will continue playing back this music and also react to remote control events. Now, before we start with this exercise, let me give you a little note here. If you run it on the iOS simulator, particularly on the iOS 8 simulator, it will not behave correctly. The problem is that iOS 8 simulator has got a bug, and that bug shows itself by not suspending any applications. So without doing any additional work, all applications that you run on the iOS 8 simulator will keep on running if they are pushed to the background. This is not the same behavior that you will see on a physical device, and it's also different from iOS 7 simulator. You will get the best experience if you do this exercise by using a physical device. iPhone or iPad will do. If you don't have that, then install the iOS 7.1 simulator. If you don't know how to install the iOS 7 simulator, we have instructions here embedded into the class materials. You can install that by using Xcode, so be sure to read into this. If you do the exercise, check out the to-do comments in the code. Here you see different steps that you have to do to make this app work in the background and to react to remote control events. If you're unsure, then refer to the steps down here. This will be the detailed information that you need to complete this exercise. When you're done with the exercise, continue with the video. Alright, so let's quickly review this first exercise. What you see here is my iPhone 6 that I mirrored to my iMac using AirPlay, so I can show you that directly on the device. The reason I already explained, there are particular problems with iOS Simulator 8, but it's also not working perfectly with the iOS 7 simulator, so really the best experience is if you test it directly on the device. So here you see the completed app. We got 3 songs here for playback, and if I tap one of the songs, it will start playing. I don't know how sensitive the microphone is, if you can hear it. Now, if I push that to the background, you can see that we have the remote controls here, and I can pause and skip forward to the next song, and it will start playing. So we are controlling our application from this control center here, and if I had the earphones connected, I would be able to use the remote control there. So let's have a look at the code to see what has to be done to make all this happen. We will focus on our music list controller here, and the first thing that we do up here in view.load is to set up our AV audio session. So here we say we need the playback category. Remember, that means don't silent the output if the silent switch is flipped, and we want to activate the category here, activate the session so we can use it. Then, in order to react to the remote control events, here in view did appear and view did disappear, I say begin receiving remote control events and end receiving remote control events. So here I register for these events and I unregister again. And down here on line around 50 something, here we are using our audio player. We call the play method on the player, and I also keep the audio player around. There's only one instance. I keep this in class scope, so it won't be collected. Here we initialize our audio player. We point it to the destination file that we want to play, and then it'll start playing. And of course, in order to make all of this work, we have to use our info plist file here. Scroll all the way down. We have to enable the correct background mode here, telling the operating system that our application will play back audio while in the background. So here we have it. If you remove that checkbox and run the app again and push it into the background, it won't play anything. In this first part of the recording, we learned what long-running tasks are, how we can use them, and we picked one of them to demo how to playback music in the background. We enabled the background mode, and we implemented all the missing parts of this music player implementation. Now we're going to move on to the second part, and that is transferring files while an application is in the background, and even better, transfer files even if our application gets terminated by iOS. We can let iOS upload or download a file even if the app is not running. The API that we are using here is very complex. So we focus on a simple version that will do downloads only. Everything we discuss here is also true for uploads. If we think back a while, the only way to download large or larger files before that API was introduced was to use the finite length tasks. Until iOS 6, we had 10 minutes to execute code in the background. And within these 10 minutes, we were able to use APIs like the HTTP client to initiate a download. So we could start the download while in the foreground it would continue for a maximum of 10 minutes. But eventually, iOS would say, you're out of time, you can't continue this download, so all threads will be suspended. So there's no chance to really download large files. And even worse, with iOS 7, the 10 minutes were reduced to 3 minutes. So practically it's no longer possible to complete any downloads because files on the web, they get larger and larger. Even though the bandwidth increases that we have on the mobile devices, the files grow even faster. And to overcome this, Apple introduced new functions, and these allow us to handle file transfers through the operating system. Here's how that works. We have our application, and the application will create upload or download sessions. Like I said, we're going to focus on download sessions. Within these sessions, you queue up uploads or downloads. And by queuing up these transfers, you're going to hand them off to iOS. This is optional, but that's the part that we discuss here today. Once iOS has completed the download, or the upload of course, it will call back to our application. And the nice thing here is not only will it call back if our application is backgrounded, it will also restart our application and then give us a callback. Each of the sessions can hold multiple related upload or download operations. Every app can have multiple sessions. An example would maybe be a browser application where you create one session per tab, so you have kind of independent processes. And we can also configure these sessions to tell iOS what our intention is. That then helps the operating system to optimize for best user experience and battery life. On a technical level, a session is an instance of NSURL session. This allows operations that are pretty similar to the features that we know from the managed HTTP client. You can upload files, download files, it supports authentication, and much, much more. We're going to focus on downloads. The concepts we discuss also apply to uploads. The sessions are driven by a configuration object and a delegate. And depending on the type of transfer that we want to perform, different configurations and different delegates will be used. There are 3 pre-built session configurations available for different purposes. We can always customize those, but most of the time one of these will be suitable for the task that we want to perform. We have default configuration that uses disk caches. You're going to use that if you download small files while in the foreground. So that's pretty much like using the managed HTTP client. Then we have the ephemeral configuration. That will keep all data in memory. It's not going to store anything on disk, no cookies, nothing. So this is something that you would use for private browsing scenarios. And then there's the background configuration. This allows uploads or downloads, and they have to go through the file system. And that's the one that we are going to use because that allows us to hand off downloads to the operating system. If we want to create such a configuration, we can use a factory method of the NSURL session configuration class. The method for background configurations, they expect an identifier. The reason for this identifier is that downloads will be continued even when our app gets terminated. And when iOS calls back to our application later, it restarts the app, it will need some way to identify the sessions or configurations, and it will allow us to reconnect to these sessions. So that's where we use this identifier later. All the configurations that we get here, whether it's the default one or the background configuration, all of these can be tweaked. So additional configuration settings are possible. Here we have an overview of what we find in there. I'm going to pick some of the more interesting ones. For instance, the Allow Cellular Downloads property, that specifies if file transfers may happen if the device is on a cellular network. You might consider setting this to false if you transfer large files. Then we have the discretionary property. That will allow iOS to schedule the start of the file transfer. It means that iOS might wait until the device is plugged into power or it has Wi-Fi reception. That's very useful if you transfer large files with a lower priority. Please note, this property is only evaluated if the transfer was started while the app is in the foreground. You can also start transfers while your app is already in the background. In that case, this flag, the discretionary property, will be ignored and it will be assumed to be true. The next one that I would like to introduce is the HTTP maximum connections per host. This one defines how many connections a specific session can have to the host. You can use this to limit the number of concurrent downloads in a session. And finally, the network service type. This again gives iOS a hint about the data type that we transfer. It allows to optimize radio and Wi-Fi settings. For instance, how fast must the Wi-Fi be started? There are more settings available that allow to set additional HTTP headers, specify cookie handling, deal with authentication, and so on. The second puzzle piece that we need to create our background download is a session delegate. This one is used to let iOS report back to us and request actions on our side. This includes information about the download or the upload progress, the errors that potentially occurred, but it also asks us to handle authentication. NSURL session supports different authentication mechanisms. That includes username, password, Kerberos, NTLM, also certificates. Depending on the type of data that we want to transfer, there are different delegates that we can choose from. All of those are subclasses of the NSURL session delegate. NSURL session data delegate is used for uploads and memory buffer transfers. We will use the NSURL session download delegate in our case here today. To create a session delegate, we have to first subclass the NSURL session download delegate and override the methods that our app is interested in. For instance, we have here did write data. Whenever a chunk of data was received from the server, this is going to be called. Then we have did finish downloading. If we enqueue multiple downloads into our session, we get informed if one of the downloads has finished. Did complete with error is a bit misleading. If you look at it, you might assume that it's going to be called if there was an error. Well, while this is true, it is also called if there wasn't an error. This method comes with a parameter, an NSError parameter, and only if that is not null, then really an error happened. Then we have did finish events for background session. This will be called if all of the enqueued downloads have been completed. And the session also supports resuming downloads. So if the server supports that, then here's your chance to resume a download. You have to take special care to support that, however. When we have the configuration and the delegate, we can finally create the session. There are overloads of the from configuration factory method that omit the session delegate. If you want to have background transfers that are handed off to the operating system, you will have to provide a custom delegate. This is mandatory. There are also callback events directly on NSURL session. You can use those alternatively to the delegates. However, again, if you want to have a background session, then you will need to implement your own delegate class, and the events will never be called in that case. Every download that we want to perform is represented by an NSURL session download task. All the tasks that are part of the NSURL session API are subclasses of NSURL session task. Again, we will pick the one that is suitable for our task here, that is downloading data. We can create download tasks by the session, and we simply pass in the URL of the file to download as a parameter. To start the download, we will call the resume method on that task. Note that there isn't an explicit start method. Resume is used to start and to resume the download. You will use the same NSURL session download task no matter what session configuration you chose. If you have configured a background session, then this download task will automatically be handed off to the operating system. Otherwise, it will be downloaded within your application only. Since the downloads are handed off to iOS, our application will not be able to see the downloaded temp file. So it will be stored outside of the application sandbox. If we implement the delegate, then eventually a callback will be triggered, and in there we get a parameter that will contain the temporary system location. And then we have a chance to copy the file from the system location into our application sandbox. There is no guarantee how long the file will remain in the temporary folder, so it's best to copy it as soon as possible. Here we have a part of the NSURL session download delegate implementation. We override the did finish downloading method. The parameters that we get here is the current session that this delegate is associated with. We get the current download task, and you can also see we get an NSURL location. This contains the location on the iOS device where the temporary download is stored. From there, we have to copy the file into our application sandbox. Usually, we will copy it to our Documents folder or maybe into the subfolder on the library. It might be tempting here to use the just regular file.copy method, the managed APIs that we have in Xamarin iOS. However, here NS File Manager is used. The reason for that is that this special location that is outside of the application sandbox can only be accessed with native API. If you try to use file.copy here, you'll end up with an error saying that the file does not exist. So we are downloading our files in the background. We have two termination scenarios. If the user terminates our application via the task switcher, iOS will stop all downloads and it won't resume them. This is very important to know, and we have to understand why Apple made this decision. So even though we hand it off to operating system, there is a chance for the user to prevent our app from downloading files. And the reason for this is that Apple said if a user removes an app from the app switcher, they don't want this app to do anything. This includes all background operations. If the app is terminated by iOS itself because it's running out of memory, then the downloads will continue. And then the app will also be restarted as soon as an event occurs. So we have seen the overrides in the download delegate. If one of the events happens, like a chunk of data was received, our app will be restarted. If an app has been restarted, it can also show a notification to the user informing him that now all the downloads have completed. And the restarted app will also appear in the task switcher. It will even have an updated UI, so we can completely prepare our application so everything looks nicely if the user comes back to it later. If an app gets restarted, iOS will trigger almost the same lifecycle methods as normally started application. It will call the finish launching method, and then it will trigger a special method that is related to background transfer. And that's the handle events for background URL method that you see here. This signals us that the app was launched due to a file transfer event. Please note that will enter foreground and did activate won't be called. The app never enters the foreground. It will be launched into the background directly. Inside handle events for background URL, we get a completion handler. If we call this handler, we let iOS know we are done handling this restart event. Now take a screenshot of our app and then suspend the app. The screenshot is then going to be shown in the task switcher. If our NSURL session instance is still in memory, iOS will call the session delegate methods afterwards. But what happens if the app was restarted, which means our session does no longer exist? Well, that's where the ID gets important. When we configured the session, we provided a unique identifier. Now here in this handle events for background URL method, iOS returns us this identifier as a parameter. We can use that to reconnect to the session that is hosted by the operating system. Reconnecting to a session is fairly simple. All we have to do is to create a configuration with the exactly same settings as we did initially. We have to provide a delegate of the exactly same type, and we have to reuse the identifier that was passed into us. If we follow these rules, our delegates methods will be called and we can handle the event that made the app restart, and we won't even notice that the app has just been started. Here we use create background session configuration. We pass in the ID. We use exactly the same settings. And we provide a session delegate of exactly the same type. If our app was restarted because all of the downloads finished, then the session delegates did finish events for background session method will be called. In there, we can update our UI, and the example above even sends a local notification to tell the user, now it's time to come back to the application, new information is ready for you. When we're done, that's the point in time when we have to call the completion handler that was given to us in the application delegates handle events for background URL method. It is very important to execute all operations on the UI thread here in case otherwise you will make your app crash. So let's go through this. We use begin invoke on man thread, where we display maybe a local notification. We can also show an alert view if we want to. And when we're done with everything, we invoke the handler that we received in the app delegate. Then our image in the task switcher will be updated. And also iOS is now ready to suspend our app because it's no longer executing code in the background. Now we're going to try that out in the second individual exercise. So let's switch over to the browser and have a look at the exercise. Here we have the instructions for the second exercise. The app that you'll be working on will download a file in the background. You can find the starter solution in the lab resources. Here's what the completed app will look like. We have a download button up here, and if you press that, it will start downloading a very large monkey image from the server. Once it has been downloaded, it will be scaled and it will show up in the UI. Down here, the blue line, that's a progress bar, so you can follow the transfer. The refresh button up here will restart the transfer. And up here, I also added a quit button. This quit button uses private API to terminate the app in a way so that the downloads will continue. So what we do with that button is we effectively simulate that iOS terminated our app due to memory pressure. You can try that out, maybe wait until the progress bar is almost done, quit the application, and then wait. Eventually, you should see a notification saying that the download has been completed. If you go back to the app, then you should see the monkey image. Again, as with the prior exercises, this will not run correctly in the simulators. So you can try it with iOS 7 simulator. That will give you the best experience with simulators, but to really see the effect, use a physical device. You'll be working with the NSURL session configuration, the NSURL session download delegate, session identifiers, and of course with the NSURL session instance that you need. You find all the detailed steps down here. Since the topic is rather complex, most of the code has already been written for you. But feel free to examine closely the solution, play around with it a bit, maybe put breakpoints into the delegate methods to see how it reacts and how it's performing this download. Let's review the completed application. If I start this completed solution, then iOS will first ask me if this application may send me notifications. The reason for this is that on iOS 8 I have to ask for permission from the user because I'm sending this local notification once the downloads have finished. I'm going to confirm that here. Then I can press the button here to start the download. You can see in the background that something is happening. It takes a while for the download to complete. We can quit the app and hopefully it will give us a notification when the download is done. You can see that the output in the background stopped, nothing here, and now let's wait for the notification to arrive. Here we have it. Here we get the notification. If I click on the notification, it will take me to the application and we see it says that all the selected files have been downloaded and in fact the monkey image is there. So we really see that the file was downloaded even though our application was terminated. Now I'm going to quickly walk you through the code here to see how this was achieved. We're going to go through it file by file. So you notice that in here in the app delegate, this is where we check if we are running on iOS 8 or above. That's when we have to ask the user for permissions to use these notification settings. In there, we also store an action that is the completion handler that we have to retain. That's the handler that we have to call if all of our transfer has been completed. And here is the override for handle events for background URL. That will be called if iOS has some events for us while the application was in the background. If the download completes while the app is in the foreground, this won't be called. So the only thing I do here is to retain the completion handler. I'm not recreating the session here, so this is different from what you saw in the slides before. The reason is that my app is fairly simple here. So the moment the app is restarted, it's also going to recreate the only controller that we have in here. That's the download controller. And that download controller creates the session in here directly. And it's always going to use the same session ID. So I don't need to worry about the specific session ID that is passed to me. I know that I only ever have one session exactly. Now let's have a look where the session is initialized. We go to the initialize session method. Here we check if we are on iOS 8 or above. Then there's a slightly different method call. We have create background session configuration versus background session configuration. But in both cases, we pass the session ID. Then we tweak some additional settings here, saying that we want to allow downloads on cellular networks. We also give it a hint about what is it we want to download. You can also say you want to maybe download video files, then the priorities will be different. We also create our session delegate here, and from the configuration and the session delegate, we finally get our session. If we want to enqueue new downloads, well, then we create a download task from a specific URL, and we simply resume that task, and that will start download. Now let's also have a look at the custom session download delegate. This contains all the methods that are triggered in case some event occurs. So here we have did write data. That created the output on the console that you saw. So whenever a chunk of data has been received, this will be called. Notice that in here we can update the UI. However, we have to invoke everything on the main thread. If one of the enqueued downloads has been completed, did finish downloading will be triggered. And in here, we get the location to the file that was downloaded. So here's our chance to copy that. We use the NS file manager in here to copy the file into the app sandbox. Again, we can update the UI here. Here we have the did complete with error method. We have to check if the error is actually null or not. Only if it is not null, then we really are in an error situation. Otherwise, we can ignore that method. If all pending transfers are done, then did finish events for background session will be called. That's where we are going to call the handler that was passed to us in the app delegate. So we check if we have that handler. We again invoke it on the main thread. And in here, I also create an UI local notification. That's the notification the user sees. And if they tap the notification, they will be taken back to our app. So there's a lot of boilerplate code that you have to write, but if you have written that once, you can obviously reuse that, so you don't have to reinvent the wheel every time. Now let's end this recording with a little flash quiz. Question number 1. A download created through NSURL session will continue even if the user manually quits the app via the task switcher. Is that true or false? That is false. Only if the app gets terminated because of memory pressure. So in other words, if iOS terminates the app, then the download will continue. If the user terminates the app, then the download will not be continued. Question number 2. How can you copy a file downloaded by NSURL session into your app sandbox? A. Use file.copy. B. Use nsFileManager.copy. Or C. It will be passed as a stream parameter to handle events for background URL. the correct answer here is B. You have to use nsFileManager.copy. That's the only API that can access this app location outside of the app sandbox. In this second part, we introduced the NSURL Session API that allows us to download files even if the app is not running. We have reached the end of this recording. Thank you for watching. If you have any questions, feel free to post on the Xamarin forums or send me an email directly.